Hey everyone, welcome. I'm so thrilled to have all of you grade 7 students here for today's explainer. We are jumping right into your exact lesson, Computer Basics Mini Project Video Overview. We're going to unpack everything you need to know to completely ace this unit project, and we'll be focusing specifically on how we built things the right way, right from the ground up.
Okay, let's take a quick look at our roadmap. We've got 5 stops today. First, the visual design misconception. Second, evidence, structure, and accessibility. Third, application, input, and model. Fourth, application, output, and limitations. And finally, transfer, beyond the project. Let's dive in.
Art 1, the visual design misconception, more than aesthetics. We're actually kicking things off with a massive myth-busting moment today.
So, is web design really just about aesthetics? Like, do you share that super common misconception that creating digital content is just about making things look pretty with nice colors and cool fonts? Honestly, it's incredibly easy to fall into that trap.
But let's look at the reality. Thinking it's all about looking pretty is kind of like prioritizing painting a house before you've even built a solid foundation. According to the Computer Science Teachers Association, or the CSTA standards, real computer science is an ethical, responsible, and human-centered practice. It's absolutely not just about visual decoration. It's really about designing functional solutions that serve diverse people and communities.
Moving to Part 2, Evidence, Structure, and Accessibility, Evidence-Based Design. This is where we bring in the hard evidence from professional industry standards that we need to actually build a correct functional website. So what is semantic HTML? Basically, it's writing code that defines the meaning of your content in a machine-readable way, which is absolutely vital for accessibility. According to the MDN Web Docs, prioritizing the semantic structure over visual styling is exactly what ensures your web content is universally understandable. And that doesn't just mean by people looking at a screen, but by assistive technologies too. Building on that, we've got the W3C Web Content Accessibility Guidelines, usually just called WCAG 2.2. They outline 4 core principles, known by the acronym POOR: perceivable, operable, understandable, and robust. These principles are pretty much the ultimate evidence of what makes a website function correctly for everyone, including folks using screen readers or keyboard-only navigation. Put simply, if your site isn't POOR, it's just not accessible. And this perfectly maps out how these professional standards connect directly to our HTML code. We have standards like CSTA Human-Centered Design and the ISTE Global Collaborator Standard. Their core goals? To write code that serves diverse communities and to use digital tools to broaden perspectives. So hitting these standards means you have to use accessible, structurally sound HTML. That is how you become a truly inclusive digital creator. All right, Part 3, Application, Input, and Model. Now we're going to explicitly break down your mini project task using a framework of inputs, models, and outputs.
Here is the exact game plan for your mini project so you know precisely what to do. Step 1, gather your inputs. Step 2, apply the model. And Step 3, generate the output. Let's look a little closer at what each of these actually means for your project.
Your crucial first step is identifying your inputs. For this project, your input is essentially organizing raw text and media. You've got to find this content and organize it using specific HTML semantic tags, things like the header tag, table tag, and main tag. Remember our myth busting from earlier? This isn't about making it look pretty yet. It's about providing the underlying structural evidence of your content.
Next up, you apply the model. The pattern here is that mapping these HTML semantic tags correctly is what directly fulfills those WCAG poor accessibility models we talked about. This relationship is vital. Proper semantic structure allows screen readers to naturally navigate the underlying logic of the page, making it operable and understandable for users with visual impairments.
Part 4, Application, Output, and Limitations. Let's look at how we measure the final results of the application phase, and crucially, where we really have to be careful.
Here's your target output in conclusion: an accessible, properly structured web page that serves diverse communities. When you achieve this, you are successfully fulfilling the ISTE Global Collaborator Standard. You're not just making a web page, you are creating a truly accessible digital space that everyone can engage with.
But, and this is a big but, there is a major limitation we have to acknowledge. Automated accessibility tools and code validators simply cannot check if a description actually makes contextual sense to a human being. They have blind spots. A computer can easily tell you if an image tag has a text description attached to it, but it absolutely cannot tell you if that description is actually helpful or accurate for the user.
Which leads us directly to this vital point. A human check is required. Manual keyboard testing and peer review user testing ensures the site is truly operable. You have to manually test your projects, guys. Literally unplug your mouse, try navigating your entire page with just your keyboard, and get a peer to review it. This human evidence check is absolutely mandatory to guarantee full operability.
Finally, we reach part 5, transfer, beyond the project. Let's talk about how this specific mini project connects to your broader education and your future in tech.
This whole mindset of prioritizing underlying structure and accessibility over pure visual aesthetics, it doesn't just apply to web design. This kind of structural thinking transfers directly to mobile app development, software engineering, database architecture, and honestly, just being a responsible digital citizen. Any future tech role you take on is going to require you to build structurally sound, human-centered foundations first.
So keep the number 4 in mind today. 4 professional industry standards, CSTA, ISTE, MDN Web Docs, and WCAG, were all united in our explainer. They all point toward the exact same goal, helping you become active, responsible, and highly skilled digital creators who build for everyone.
I want to leave you with this provocative question to think about as you start your work. How will you use structure and accessibility to ensure your digital voice can be heard by everyone? Really think carefully about your foundation. Thank you so much for joining me for this Computer Basics mini project video overview. STEMit Unit 07 Lesson Pack 03 Computer Basics mini project video overview.